Hey everyone, this is Unit 11, Lesson 7, Dividing Segments Proportionately. For the do now, we're going to draw a right triangle ABC with the right angle located at angle C in quadrant 2. So let's remember where our quadrants are. Quadrant 1 is where all of our points, X and Y, are both positive. Then it seems to go backwards, but that's actually the direction of a positive rotation. So because they want angle C in the second quadrant, we're going to put the right triangle this way, as opposed to going over and then up. So I'm just going to connect these two points, forming our right triangle, and we're going to call this point C. It says determine and state the length of line segment AC. So that's easy. We're just going to count boxes. So when you're counting your boxes up, you should get 8 units. Now you're going to determine and state the length of line segment BC. So B is here, C is over here. You're going to do the same thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that's going to be 16 units. Now they say determine and state the length of line segment AB. Now line segment AB is a diagonal line. So what we're going to have to do is we're going to have to actually use this right triangle and use the Pythagorean theorem to find the length of segment AB. So A is going to be 8 units, B will be 16 units, and we're going to find the length of AB. A squared plus 16 squared equals C squared. And A squared plus 16 squared is 320. And when I did the square root, because the opposite of squaring is square rooting, I noticed that this is not a perfect square. It didn't say to round, so I'm actually going to leave my answer as a square root of 320. And that is the length of segment AB. If you want to round, just make sure that you round correctly. All right, I'll meet you on the next question, and please plot the points. All right, so guided practice says plot the points, plot the segment containing the 2 points. So I went -2 on the X, 1, 2, 3, 4, 5, 6, 7, 8 units on the Y, and I labeled that point A just so that I can refer to it. And I'm going to call this point B, and that's at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then down 4. 1, 2, 3, 4. Okay, so now it says using a compass, determine and state the point on the directed segment from point A to point B that divides this segment, this line, into a ratio of 1 to 1. So basically what they're asking you to do is find the midpoint. So take your compass, put it on A, choose a radius more than half, swing your radius from point A, then turn your paper, and you're going to do that same point from point B. Like this, and then when we connect, we're going to find the midpoint, which is going to be right here, and that's going to be at point 1, 2, 3, 4, 1, 2. So 4 units on the X, 2 units on the Y, and that is going to break our segment into a ratio of 1 part here and 1 part over here, so 2 parts total. Guided practice. It says we will no longer use the compass as we are not locating the midpoint anymore. State the coordinates of the point on the directed segment from -1, -2, so X comma Y. So -1 on the X, -2 on the Y. I'm going to call that point A, and we're going to end at 4, 8. So over 4, 1, 2, 3, +4, 1, 2, 3, 4, 5, 6, 7, 8. I'm going to call that point B just so that we can refer to it. And we want to divide this into a ratio of 3 parts to 2 parts. So step 1 is to plot the segment. And if you have your straight edge, you should always use that to connect your 2 points. Then it says determine the total parts. Well, to do that, you're just going to add the 2 parts. So we have a total of 5 parts, 3 plus 2. Now it says state the slope of the segment. So remember, slope is going to be the change in Y over change in X. So from point A, we're going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up 10 units, and then from that point, 1, 2, 3, 4, 5. So just like what we did on page 1, where we made that right triangle, that's how you find the slope, up and over, the rise over the run. Now it says divide the slope by the total parts. So remember there was total of 5 parts, so we're going to divide each part of our slope by our total of 5 parts. So 10 divided by 5 is 2, 5 divided by 5 is 1. Now we're going to use this simplified slope to find the point beginning at the first point. So starting at point A, we're going to go up 2 units and then over 1, plot a point. Up 2 units, over 1. And you're just going to keep doing that until your line segment is divided into 5 equal parts. Okay, so if you end up doing this and you don't end up back on your line, then you know you made a mistake. So now look what we have. We have 1, 2, 3, 4, 5 equal parts. So what do they want? They want 3 parts closest to A. 1, 2, 3, that's going to be here. That's going to be 3 parts, and then 2 parts closest to B. So 3 to 2, it's going to be this point right here. So that point is located at, starting at the origin, 1, 2 units over on the x-axis, and then 1, 2, 3, 4 units on the y-axis. And that's how you divide a segment into equal parts. So now, using those same steps, we're going to do example number 1. State the coordinates of the point on the directed segment from, I'm going to call this point A just so that it's easier to refer to, 1, 2, 3, 4, 5, negative 6, 1, 2, 3, 4, negative 5. Okay, that's A. And then we're going to end up at positive 4 and 0. Okay, that's going to be point B. And we want to divide this segment into the ratio of 2 to 3. So how many total parts do we need? Well, 2 plus 3, that's going to be 5 total parts. So step 1, we plotted the segment. Step 2, we determined the total parts. Step 3, find the slope. So remember, slope is change in y over change in x. So starting at point A, we're going to form that right triangle. 1, 2, 3, 4, up 5 units on the y-axis. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units on the x-axis. Now we're going to divide that slope by the total parts we want. We want 5 parts. So we're going to divide each, the numerator and denominator, by 5. 5 divided by 5 is 1. 10 divided by 5 is 2. So now we're going to start at point A and we're going to use our simplified slope. Up 1 on the y-axis, over 2 on the x. And notice how I ended up back on my line. Up 1, over 2. Up 1, over 2. And remember, you can always pause the video and go back and just go at your own pace. So notice how I now have 5 equal parts. And we want the one point, which one of these points divide this segment in a ratio of 2 parts closest to A and 3 parts closest to B. And that's going to be this point right here, which is located at, starting at the origin, negative 2 on the x-axis, and then 1, 2, negative 3 units on the y-axis. So this is the point that divides a segment into 2 parts closest to the first point and 3 parts closest to the second point. Excellent job. Example number 2, we're going to state the coordinates of the point on the directed segment from negative 2, positive 1, that's going to be this point here. Again, I'm going to call that A just so that we can refer to it. Starting at the origin, 1, 2, 3, 4 units on the x-axis, 1, 2, 3, 4, 5, 6, 7 units on the y-axis. And again, if you have a straight edge, it's always great to use that. And it doesn't have to be a compass, could be a side of a piece of paper, the calculator, anything that's straight. Okay, how many parts do we want? We need 2 plus 1, so we need 3 total parts. Next step, find your slope. Slope is the rise over the run. So from point A, 1, 2, 3, 4, 5, 6 units on the y-axis, 1, 2, 3, 4, 5, 6 units on the x-axis. So our slope is rising 6 over 6. We want to divide this into 3 parts. So 6 divided by 3 is 2. 6 divided by 3 is also 2. So starting at point A, we're going to go up 2 units, over 2 units. Notice how I'm back on my line. Up 2, over 2, back to the line, up 2, over 2. Notice how I now have 3 equal parts, and we want the 2 parts closest to A, and we want 1 part closest to B. So this is our ratio of 2 to 1. It's going to be this point here. 1, 2, 1, 2, 3, 4, 5. So our point is at positive 2, positive 5. Excellent job. Next question. Point Q is on line segment MN such that MQ is to QN is equal to 2 units is going to be closest to MQ and 3 units closest to QN. If M has coordinates of 3, 5, 1, 2, 3, 1, 2, 3, 4, 5, we're actually going to call that M, and N has coordinates of 8, 5. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. Okay, so here's line segment MN, which means Q is going to be somewhere in between. Determine and state the coordinates of Q. All right, so we want to have total of 5 parts. Total parts is going to be 2 plus 3, which is 5. Next, we're going to find the slope, the rise over the run. Well, from point M, we're not going up or down anywhere, so that's going to be 0. And then we're going over 1, 2, 3, 4, 5 units. And we want to divide each of these by 5. So 0 divided by 5 is 0. 5 divided by 5 is 1. So we're going to go 0 on the y-axis over 1 on the x. 0 on the y over 1 on the x. So obviously this one's pretty simple. All right, we have this into 5 equal parts. So now we want MQ to have 2 units, and we want QN to be 3 units. So it's going to be this point right here. So that's going to be at 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So positive 5 on the x, positive 5 on the y. So point 5, 5 is where Q is going to be located. Example number 4, it says in the diagram below, line segment AC has endpoints with coordinates at A, -5, 2, and C, which is already plotted for us, at +4, -10. If B is located on line segment AC, and this distance from A to B is going to be 1 part, and B to C is going to have 2 parts, 1 plus 2, we're going to have 3 total parts breaking up this line. What are the coordinates of B? So what you're doing is, remember, you can always turn the page back. We're just following these same directions. Plot the segment, determine the parts. Now we're going to state the slope. Then we're going to divide the slope by the total parts. We're going to use our simplified slope and state the coordinates. So remember, slope is always change in y over change in x. So from A, remember, we're basically forming that right triangle. We're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, but we're going down 12 units. 1, 2, 3, 4, 5, 6, 7, 8, 9 units over to point C. We want to divide this line into 3 equal parts. So -12 divided by 3, -4. 9 divided by 3 is 3. So from point A, we're going to go down 4 and then over 3. And notice how we end up back on our line. Down 4 and over 3. Down 4 and over 3. And now our line segment is broken up into 3 equal parts. So what do we want? We want AB to have 1 part. So from A to B is going to be 1 part. And from B to C is going to have the 2 parts. So therefore, point B is right here. So starting at the origin, we're going -2 units, -2 units. So since this is multiple choice, the answer is there for us. It happens to be choice 1. All right, example number 5, I got a little head start. It says point P is on the directed segment from X, so starting from X to point Y, and it divides the segment into a ratio of 1 to 5. So remember, first thing you want to do is plot your points, connect your segment, and find out how many total parts you want. The next step is to find your slope. So from point X, we're going to form that right triangle, 1, 2, 3, 4, 5, 6, 7, 8, up 9 units, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now we're going to divide each of these numbers by 6 because that's how many parts we want. So when we do 9 divided by 6, we get 1.5. And 12 divided by 6 is 2. So starting at point X, we're going to go up 1.5 and then over 2. And notice you're back on your line. And keep doing that. Up 1.5 over 2. Up 1.5 over 2. Up 1.5 and then over 2. Up 1.5 and then over 2. Up 1.5 and then over 2. So now you have 6 equal parts. And we want this to have a ratio of 1 to 5. So it's this point right here. So 1, 2, 3, -4, -1/2. Choice 4. Okay, you guys are doing a great job. Remember to always pause the video whenever you feel like the person that is doing the video, myself in this case, is going a little bit too fast. You're going to copy all your notes. You're going to try this independent practice on your own. Don't forget to take a picture or scan of each of your pages and attach it into the Canvas forum. And we'll see you on the next video. Have a great day.